A bead at a distance of small r, bead at a distance of small r, right? This is rotating with a uniform angular velocity omega at this instant. So this will have a tendency to move outwards, right? This will have a tendency to move outwards. When it comes to the outermost edge, you are not providing an external torque. This is rotating on its own. When it comes to the outermost edge, they are asking what will be the angular velocity. I1 omega 1 will be equal to I2 omega 2. This rod is massless. So I1 omega 1 is equal to I2 omega 2. This will be mr square into omega 1 is equal to ml square into omega 2. Mr square omega. Omega is given initially. This is omega naught is equal to ml square omega 2. Omega 2 is equal to r square by l square into omega. Right? All questions in this subcategory will be the same way. They will tell you this is a disk. We will reconnect it, right? इनको सभी स्क्रीन दिख रहे
हैं अभी से बोर्ड दिख रहा है सभी सेंटर से अभी से बोर्ड व्यू हो रहा है
थाने सेंटर से ये सब
ओके
They will tell you there is a man.
हाँ सर सही है सर
There was a man standing here. He walks out radially. If this is omega naught, when he comes to the outer edge, if this is r and this is capital R, same concept you will apply. Take the initial angular momentum, take the final angular momentum. Questions asked in this subcategory in the other CET entrance examination, they said if a radius of earth shrinks to half its present radius, I1 omega 1 is I2 omega 2, right? Quite a few questions in rotational dynamics are being asked on conservation of angular momentum on pure rotation. Pure rotation is I omega, that should remain constant. Last year they asked about moment of inertia of a solid cylinder about an axis perpendicular to it. I'll speak about it, take it out earlier. 2015 paper, I was actually surprised to see this question at CET level. This question is a question with integration. You just cannot, either you should know the formula previously, memorized it and you might have gone, or they mistook this to be something and they have given. 2015 May, that too in medical entrance examination. 2015 you didn't have CET, right?
Yeah.
The medical entrance, they asked what is the moment of inertia of a cylinder about this axis of length L. About this axis, solid cylinder ka is quite easy, same as that of disc. Solid cylinder ka, this will be mr square by 2.
Yes.
I have a feeling they mistook something to be perpendicular axis theorem and they gave this question. They gave the answer as mr square by 4 plus ml square by 12. But perpendicular axis theorem cannot be used for this. Perpendicular axis theorem is applicable only for thin laminas. 2D objects, perpendicular axis theorem, please do not use it for 3D objects. Then what is the actual way that you solve this? In medical entrance, so much of an integration I don't expect. Whoever set the paper committed a blunder. 2015 May. Consider a small element at a distance of x of thickness dx. What will be the small element in a solid cylinder? A disk. Small element in a solid cylinder will be a disk. So as far as the disk is concerned, what will be the moment of inertia of this? dm r square by 4 in the plane of the disk. The plane of the disk is like this. Why are you interested in moment of inertia about this axis? This is dm r square by 4 because only then I can translate it about a parallel axis, and I am interested in moment of inertia of this disk about this axis. Why? That I will integrate from minus L by 2 to plus L by 2. I cannot add or subtract moment of inertia if they are not about the same axis. They should be about the same axis. Now integration is nothing but summation. For me to calculate the moment of inertia of this small element about this, I will have to use parallel axis theorem. That means this disk, if I take this way, I want the moment of inertia about this axis.
Yes.
So di will be equal to dm r square by 4 plus dm into x square.
Yes.
Now I got di about this. Moment of inertia of the small elemental disk about an axis passing through the center. This I can integrate, provided I substitute for dm properly. Mass per unit length into the length of the element is dx. R square by 4 plus mass per unit length into dx into x square. This will be di. This I will have to integrate. Mr square by 4l integral dx from minus l by 2 to l by 2. Mass per unit length integral x square from minus l by 2 to l by 2. Mr square by 4l into integral dx is x, l by 2 minus of minus l by 2 will become l, plus m by 3l, this will be l cube, x cube by 3. This will be l cube by 8 plus l cube by 8. Am I right?
Yes.
This will turn out to be mr square by 4 plus m l square by 12. They might have mistook using perpendicular axis theorem as the means. I do not expect a CET level, that too medical entrance examination, to involve so much of integration. This is the right way. Then probably the formula is given with the expected the student to memorize the formula. But this is the way you get it. Clear? Solid cylinder about an axis perpendicular to the cylinder passing through the center. Remember the formula. In the CET you will not have so much time to answer these questions. Directly they gave the formula. In your HSC textbook directly they gave the formula. So they asked this question as it is. The other formula which was exploited in other CET entrance examinations were annular ring. Inner radius is A, outer radius is B. I will be ma square plus b square by 2. How did you get this formula? M is the mass of the leftover piece. Right? I got this formula by capital M b square by 2 minus removed part is m naught a square by 2. Substitute capital M and m naught, you will get, in terms of m, you will get m a square plus b square by 2. Here, remember this formula. They make annular ring. This is called an annular ring with an inner radius and outer radius. Inner radius A. That means from a disk of mass capital M, I remove a disk of mass m naught. I get the answer. Capital M and m naught I will have to substitute in terms of m. I will get this answer. Disk connected to, this is of mass capital M, radius r small m. This set of questions are very famous with different CET entrance examinations. This is a disk, you are keeping small m, you release it. After falling by a height of h, they want to know the velocity of this. One way is to solve using dynamic equations, but the quickest will be conserving energy, because there will be no slipping between the string and the cylinder. So the conservation of energy is mgh loss is equal to half small mv square plus half I omega square. I will be capital Mr square by 2, omega will be V by R. One equation, one variable, your job will be done. Right? Somehow several CET entrance examinations have been asking questions on this. Right? The other way of dealing with this, if you want the dynamic equations, you can pick up this mass, keep it here. You can pick up this mass and keep it here if you want the dynamic equations, but they are not asking you for the velocity. If they are not asking you for the velocity, only then do that. You have a cylinder here. You picked up this mass, kept it here. This will be mg. So mg into r will be torque equal to I into alpha. I is capital Mr square by 2 plus mr square. Once you get alpha, you will calculate angular velocity from that. From angular velocity, you will be able to get linear velocity. Instead, I would suggest go by this, because see the requirement in the problem. They are asking for velocity, go with this. They are asking for alpha, go with this. Right? In this, once this is V equal to R omega, which will be equal to this V. That is what you put omega as V by R. How did you put omega of this to be V by R? Velocity of this with respect to center of mass is R omega, plus velocity of center of mass with respect to the ground is 0. So velocity of this with respect to ground is R omega. That you equated it to V. Clear? That you equated it to V.
Can you explain that method again?
This one?
Yes, sir.
Loss in potential energy is equal to gain in kinetic energy of both. Kinetic energy of this is half mv square. Kinetic energy of this is rotational, half I omega square. Why did you put I value capital Mr square by 2? I know it's a test. Omega, why did you put V by R? Velocity of this point and this point should be the same. If this is V, this is velocity of this with respect to center of mass is R omega, plus velocity of center of mass with respect to the ground is 0. So velocity of this point with respect to the ground is R omega. That and this I equated. You will get V equal to R omega. So you substituted omega as V by R. You directly get velocity from here. What they are asking is the velocity. If they ask for accelerations, do this. Pick up this mass and fix it up here. Only thing, take I as capital Mr square by 2 plus small mr square. Now, very technically, how do I solve this? If you are asking me for alpha, I should write the equation. This is T and this is T. My equation here is mg minus T is m into A. My equation here is T into R is I into alpha. Right? T into R will be capital Mr square by 2. Alpha will be A by R. Why is alpha A by R? This is A and this is R alpha. Acceleration of this point and this point should be the same. Acceleration of this with respect to center of mass is R alpha. Plus acceleration of center of mass with respect to the ground is 0. Hence acceleration of this point with respect to ground is R alpha. Agreed? When I equate that, I get this equation. Substitute this T here. Cancelling out R, mg minus capital Ma by 2 is small ma. Mg is equal to small m plus capital M by 2 into A. If I simplify that, am I getting this? Alpha is A by R. Alpha is A by R. Are both the equations same? So now you understood why I picked up this mass small m and placed it here. Now I take the moment of inertia of whole of the system. Moment of inertia of the disk plus moment of inertia of the small mass m. Who gave you the permission to place it? This length of the string is negligible. This length of the string is of negligible mass. It doesn't have any mass. So I can pick up this mass and place it here. I will get the same answer. Body is rolling down an incline. Body is a disk, solid cylinder, mass m, radius r, theta. This is of height h. Right? This is of height h. It rolls down till here. And this is theta is equal to say 37 degrees. Theta is 37 degrees. This distance S is smooth. This distance S is smooth. Let me take this to be 1 meter. It is rolling down from here. They asked you for velocity at the lowermost point. It is rolling down from here. They asked you for the velocity at the lowermost point. See, it's quite easy for you people to calculate the velocity when the body is rolling. But from here, it is smooth. So whatever omega the body acquired till here, thereafter the omega will remain
Same.
only with the linear velocity will increase. Take this to be 1 kg, mass is 1 kg, radius is say 1 meter. I am giving you very convenient numbers to make your job a bit easy. Small g is 10 meter per second square. 10 meter per second square. Find the kinetic energy of the disk when it reaches the lowermost point. Kinetic energy of the disk when it reaches the lowermost point.
H is the total height from ground level?
H is the total height from the ground level. Right? So now this distance is 1 meter. So you know what will this particular distance be? H by sine 37 minus 1 meter. Isn't it? That length will be H by sine 37 minus 1 meter. Yes or no?
Yes.
Now this loss in potential energy, see, do the vice versa. You asked me that, so I gave you the distance, but then do you people remember the value? What will this height be? If this is S, this will be S1 sine 37. So what is the height by which this mass has come down? mg h minus 1 sine 37. Agreed? That loss in potential energy will be converted into gain in kinetic energy. Half mv square plus half I omega square. Half mv square plus half mr square by 2. Omega square is v square by r square. This will be 3 by 4 mv square. This will be mg h minus 1 sine 37. Getting the velocity from here is not a big deal. Once I give you the masses, masses will get cancelled out, so I am never worried about it. If h is given, job becomes much easier. Once I have got that, see what happens to the problem. Here I know v and I know omega. Here I know v and I know omega. Agreed? Why didn't you take the work done by friction? Work done by friction here will be 0. Why? Body is rolling. Whenever the body is rolling, point of contact is at rest with respect to the surface. Now what is your kinetic energy? I know the kinetic energy now here, right? Now when it comes down further, by what distance does it come down? This is 37. This will be 1 sine 37. mg into 1 sine 37. Loss in this potential energy will go only into half mv square. Whatever is the omega that you have calculated here, this omega, it will remain with the body constant. Right? Now this goes only into half mv square. Why? There is no friction here. Right? Now this loss in potential energy is equal to half mv square minus half mv naught square. I will call this v naught. Loss in potential energy is equal to gain in kinetic energy. This is the final velocity, this is the initial velocity. Right? If I get v, I already know the initial omega. How do you know the initial omega? V naught by r. You get v naught from here. Right? What is your final answer? Your final answer is half I omega naught square. This is omega naught square plus half mv square. The final linear velocity that I get here plus the omega naught I had here. From here omega will remain constant. Are you getting that point? Till here the body was rolling. V and omega were changing such that the body is rolling. Did I calculate that value from here? Yes. After getting V naught, omega naught is equal to V naught by R. So this energy of half I omega naught square will remain with the body as it is. It will not change. But the decrease in potential energy from here till here will go into the kinetic energy. Decrease in potential energy will be equal to gain in kinetic energy. Final minus initial. Andhra CET, they have asked this question this way. They gave you 3 thin rods, identical rods of mass m and length l, forming an equilateral triangle. Then they said find the moment of inertia about an axis passing through a perpendicular to the plane inwards about an axis passing through a perpendicular to the plane. They want the moment of inertia of this. All that you will do is calculate the moment of inertia of all three thin rods about this axis and add them up. Addition or subtraction is done only if they are about the same axis. So I know the moment of inertia of this thin rod about this. I know the moment of inertia of this thin rod about this. Because they are ml square by 3. Just find out the moment of inertia of this about this axis and add them up. Quick. Now listen. About the moment of inertia, I will be equal to I1 plus I2 plus I3. I1 will be ml square by 3. I2 will be ml square by 3. I1 is for AB and I2 is for AC. Now moment of inertia of BC. I know the moment of inertia only about an axis passing through its center perpendicular to it. But I cannot directly add that. Why can you not directly add that? I can add all the moment of inertias only if they are about the same axis. So moment of inertia of this about this axis is ml square by 12. Now use parallel axis theorem to translate it about it. Do I know this distance d? I know this is L, this is L by 2. D will be root over of L square minus L square by 4, L root 3 by 2. Now what will I3 be equal to? ml square by 3 by 12 is the moment of inertia about an axis passing through the center plus m into d square. M into d square. What is d? L root 3 by 4. Add all of them, you get the answer. Height h, hollow sphere, solid sphere, solid cylinder, rolls down a rough inclined plane, rolls down a rough inclined plane. Velocity of the hollow sphere at the lowermost point greater than the velocity of the solid sphere, greater than velocity of solid cylinder. Velocity of this solid sphere less than velocity of the solid cylinder. Velocity of the hollow sphere greater than velocity of solid sphere, lesser than velocity of solid cylinder. Velocity of the hollow sphere when it reaches the lowermost point, which will have greater velocity than which? When it reaches the lowermost point, which will have greater velocity than which? Listen, if the body is rolling, always remember V is equal to root over of 2gh by 1 plus k square by r square. All that you need is value of k square by r square. Right? For a hollow sphere, 2 by 3 is k square by r square for a hollow sphere. Solid sphere, this is 2 by 5. Cylinder, it will be 1 by 2. Solid cylinder. Right? Solid cylinder will be mr square by 2. So it is 1 by 2. Now once you have that, watch out for this. K square by r square. K square by r square. Which among them is greater? Give me the inequality for them. See, 2 by 5 will be lesser than 2 by 3. 2 by 5 is lesser than 2 by 3. Great. Half will come in front or behind? Right? So this is for solid, hollow, solid cylinder. Now, greater the value, lesser is the velocity. Greater is the value, lesser is the velocity.
So half is not greater than 2 by 3.
Half will?
Half reach by 0.66. 2 by 4.
This will be 1 by 2, this will be 2 by 3. Am I right? This is 0.5. How much is 2 by 5?
0.4.
0.4, 0.6. Perfect. Now, see, that means this will be solid cylinder, this will be hollow sphere. Now this comes in the denominator. If this is greater than this is greater than this. Greater the value, lesser the velocity. Now the inequality will change. Velocity of the solid cylinder, solid sphere will be greater than velocity of solid cylinder will be greater than velocity of hollow sphere. Velocity of the solid sphere will be greater. The inequality will get reversed because greater the value, lesser the velocity. Now, velocity of the solid cylinder sphere will be greater than the velocity of the solid cylinder will be greater than the hollow sphere. Remember this formula, that's important. And acceleration will be g sin theta upon 1 plus k square by r square. Suppose if he tells you the inclined plane was smooth, how will your answer change? By the way, one important assumption which I took here, all three are of the same masses and the same radius. Right? All three are identical masses. That's important. Fine, you cancelled out the masses. You did the comparison only with k square by r square. Now, what if the inclined plane was smooth? All will have the same velocity when they come down. This is independent of mass. Acceleration and velocity is independent of mass. Independent of mass. If he gives you solid sphere 2 times the mass of hollow sphere, how will your answer change? In the velocity, do you have any mass here? It doesn't. So it need not have identical masses. We are not concentrating. Listen, this velocity is independent of mass.
So, but for a smooth incline, the masses have to be same to different.
Why? V is under root 2gh. It gets a smooth incline ले लिया आपने. Loss in potential energy is equal to the gain in kinetic energy. Right? V is under root 2gh. This is independent of mass. This problem is independent of mass. Keep that in your mind. mk square. K square by r square, how do you calculate? For a solid sphere, 2 by 5 mr square is equal to mk square. 2 by 3 mr square is equal to mk square. Mr square by 2 is equal to mk square. So mass gets cancelled out all throughout. These are independent of masses. They can give you a combination with different masses. They are just playing with you people. Hollow sphere of mass m naught. Hollow sphere of mass m naught. Hollow sphere of mass m naught is moving with velocity v and rolling angular velocity omega naught. He is filled with water of mass m. Water of mass m. Find the kinetic energy of the system. Hollow sphere of mass m is filled with water of mass. Hollow sphere of mass m naught is filled with water of mass m. Water will not have rotation. Sphere ka both rotation and translation. Here the key catch is water's moment of inertia will not be defined. So for the hollow sphere, I will write half m naught v square plus half I naught omega square. I naught will be 2 by 3 m naught r square. This is the kinetic energy of the hollow sphere. Water ka you will just add half mv square. Water ka you will add half mv square. Water, the question is mainly given to verify if the student knows that water doesn't have rotational kinetic energy. Rather, moment of inertia is defined only for a rigid body. I is defined for a rigid body. 2009 JEE question. Three questions from rotation have been asked to that year. 2009 they asked Find the moment of inertia. Listen to this. Moment of inertia of a rod of mass m and length L about an axis passing through a point midway between the center and the end. Midway between the center and the end. That means this will be L by 4. No big deal. This will be ml square by 12. ml square by 12 plus m into L by 4 whole square. ml square by 12 plus m into L square by 60. Write the next question, solve this. Moment of inertia of a big drop is capital I. Here actually technically they committed a blunder. Drop means liquid drop. Liquid car should not be defined. But either way, don't find faults with them. We need a seat, give them what they need. Right? Moment of inertia of a big drop is capital I. Full stop. If 8 droplets are formed from this big drop, if 8 droplets are formed from this big drop, find the moment of inertia of each small droplet. Consider the volume first.
So 1 by 32 of I.
2 by volume will be 4 by 3 pi r cube is equal to 8 times 4 by 3 pi small r cube. So small r is equal to r by 2. So each drop, if this is I, this is 2 by 5 mr square. I dash will be 2 by 5 m small r square. This is 2 by 5 m. Small r is r by 2 whole square. 2 by 5 m r square by 4. This is I by 4.
So the mass will remain.
Sir, even the mass will increase by
Mass will also change. You are right. This will become m by 8.
Yes.
M by 8. M by 8.
I by 32.
I by this is a good question, write down. Can I proceed? In 2009 में they asked 4 questions from this subtopic of rotation. Huge slot. Moment of inertia, write down. Moment of inertia of 2 freely rotating bodies, A and B. What are the bodies? He didn't tell you. 2 freely rotating bodies. Moment of inertia of 2 freely rotating bodies, A and B, are IA and IB. Moment of inertia of 2 freely rotating bodies, A and B, are IA and IB. If IA is greater than IB and their angular momenta are equal, K stands for kinetic energy. Actually, they did a very foolish thing here. If either C or D is right, then B is also right. They shouldn't have given you such an option. That too when there is only single choice question. If either C or D is right, then B is also right. That means more than one option is correct. But as the saying goes, we need a seat, we don't want to find faults with them. Quick. Now listen. IA is greater than IB. The moment of inertia of this is greater than this. Now what he says is that if K and KB are their kinetic energies, quite a few flaws in this particular question. You know why? Freely rotating bodies A and B. Two freely rotating. Okay, there we can pardon them. Rotation means let me take only rotational kinetic energy, half I omega square. If you don't tell that, I'll have to take even half mv square. But freely rotating bodies means, let us say, assume it is pure rotation. Though that is not the right terminology. Right? Half Ia omega square. Now if it is the same angular momentum, Ia into omega A will be equal to IB into omega B. Right? So kinetic energy half I omega square. Can I use this relation between L? L square by 2I will be kinetic energy. LA is I omega, I square omega by 2I. Do I get half I omega square?
Yes.
So kinetic energy I can use this relation. Why are you using this relation? Only if I am taking pure rotation, which has been specified. Second, you gave me the relation in L. You told me both LA and LB is equal. So kinetic energy, if I take EA, is equal to L square by 2IA. EB is equal to L square by 2IB. Now obviously you know how to go about with this. You gave me IA is greater than IB. EA will be K. EB will be greater than C. Now if this is right, obviously this will also be right, which they didn't observe while giving these options. And CET is only single choice correct. You cannot give more than one answer correct. The fourth question that they asked in 2009 from rotation is moment of inertia of an annular ring. 90% of your questions in CET for rotational dynamics are coming from moment of inertia. Go through the formula carefully. एक center उड़ गया यार, चेंबूर शायद.
इसका स्विंग ऊपर साइड कर दो. सर रिकरेक्ट करना होगा.
Now, when you are speaking about oscillations, the basic structure is SHM. I have seen 90% of your questions in SHM are coming from time taken for it to go from one part to another part. 1 year they asked you what is the time taken by an SHM to come from extreme to half the amplitude, extreme to 1/3 the amplitude, extreme to 3/4 the amplitude. Now, the best way to solve such type of questions in SHM is use the phasor. Particle is going from here till here. When the phasor is here, and what will omega be? Omega will be angular frequency. That will be omega for the SHM. For the phasor particle, that will be the angular velocity and uniform angular velocity. When the particle is going about in a circular track, the foot of the perpendicular is performing SHM. This is your definition of SHM, if you people remember. When the phasor particle is going in a circular track, the foot of the perpendicular is doing SHM. Right? So when the particle is here, the foot of the perpendicular is here, that is performing SHM. Now the question is, how much time will the foot of the perpendicular take in coming from the extreme position to half its value? How much time will the foot of the perpendicular take to come from the extreme position to half its amplitude? This was the question asked. See the ease with which you can solve if you are using phasor. Right? This distance is A by 2. Am I right?
Yes.
This distance is A. What will this angle be?
60 degrees.
60 degrees. Right? initially when the particle is here, what will this angle be? 0. So if you know the omega, he gave you the time period. Time period is 2 pi by omega. If you know the omega, can you calculate the time taken by the particle to turn by an angle of 60 degree? Here the angle which it makes is 0. How much time will it take to come till here? So time will be equal to 60 degrees, rather pi by 3 by omega. This is the time taken by the particle to come from the extreme position to half its amplitude. Time taken by the SHM to come from extreme position to half its amplitude. Tomorrow if he gives you A by 3, A by 4, A by 8, A by 10, anything that he gives you will be able to calculate. Yes or no?
Yes.
Particle is going about in constant angular velocity. Foot of the perpendicular is performing SHM. Make a note of it. This question is the most popular question for you people in the CET. Extreme to half the amplitude to extreme. From half the amplitude it came to the extreme. That means what is the angular displacement? It will be this complete angular displacement. Just recognize from which point to which point he is asking you for the transition. Spring mass system. The other thing that they are playing with in this particular chapter is V is omega root over of A square minus Y square. They are using this formula quite frequently. They are giving you different positions of Y and they are asking you different values of V. Please be alert with this. Simplest possible questions that you will never ever go wrong. The only thing is that you are in a hurry to solve. They are giving you less time. They give you dirty numbers like Y is equal to A by 18. Right? They have given you. Their simplification will be uncomfortable. But for that, there is no big deal in it. Right? V maximum is something that they are again playing with. That is A omega. Right? What if you are speaking about acceleration? Minus omega square Y. A maximum is minus omega square A. If you are seeing the extreme position, here acceleration is maximum. Sorry, here acceleration is 0. Here acceleration is maximum. A is maximum. Here it is 0. When you are taking the extreme position, here velocity is 0. Here velocity is maximum. Right? At the equilibrium position, acceleration is 0. Velocity is maximum. Right? Second point, time period 2 pi under root m by k. Irrespective of whether you keep it vertical, whether you keep it on inclined plane, whether you keep it on horizontal plane, time period will be the same till when you do not change k. Even if you are keeping it inside an elevator, time period will be the same. Time period doesn't change for any of them. Spring mass system. Inside an elevator, the equilibrium position may change, but the time period will be the same. You have kinetic energy half m omega square A square minus Y square. Potential energy half m omega square Y square. One question very popular with the CET people is the point at which kinetic energy is equal to potential energy. Because the graph for this, you will be drawing it this way, where kinetic energy is decreasing, potential energy is increasing. They want to know this point of intersection. This will be half m omega square A square minus Y square is equal to half m omega square Y square. This will go, omega goes, A square is equal to 2Y square, Y is equal to A by root 2. That's the distance from the mean position. Y is always measured from mean position. Measured from mean position.
Plus minus.
Obviously plus minus. Above or below the mean position. A particle executes SHM with a time period of 8 seconds. SHM with a time period of 8 seconds. They are asking you find the time in which half the total energy is potential. Time in which half the total energy is potential. Now what is the total energy? Half m omega square a square. Potential, half the total energy is half m omega square y square. Now first of all you get the value of y. Cancelling out these both, you are left with a square by 4 is equal to y square by 2. Y is equal to a by root 2. Now how much time will it take for a to come from this is a, your requirement of y is a by root 2. That means this should be a by root 2. That means this angle is 45 degrees. You know the time taken by the particle to come from A till here. I told you this is a subset where maximum number of CET questions are being asked. Time taken by the particle to come from here till here. This is the total energy, right? 45 degrees, you know theta by omega. He gave you the time period, you get omega. One more point that they have been hitting on is a damped oscillation. For a damped oscillation, your HSC textbook gives this diagram. A spring mass system with a vein inside. He calls this vein inside a liquid. This is M and K. They call it a vein. This is block, this is a vein. In a viscous liquid, once it is oscillating, this will be a damped oscillation. Now, technically, what will be the restoring force? It will be directly proportional to the velocity of this damped oscillation. It will be directly proportional to the velocity of this. They are calling it by some constant B minus Kx. Right? B is the damping constant. B is the damping constant. Now this will be m d2x by dt square is equal to minus b dx by dt minus kx, or m d2x by dt square plus b dx by dt plus kx is equal to 0. This is the second order differential equation which will be beyond your scope. Hence they directly give you the solution of this. Solving this will be beyond your scope. Hence x is equal to a e to the power minus bt by 2m. They gave cos omega dash t plus 5. You differentiate this twice and you see you will get that answer. Right? You differentiate this twice and see you will get that answer. Last year in the JEE mains they gave a question on this amplitude. They said in 5 seconds the amplitude falls to 0.9. Now in the next 5 seconds or 10 seconds, what will the amplitude fall to? Amplitude means you will take only this. Amplitude A dash will be a e to the power minus bt by 2m. If in 5 seconds this becomes 0.9 times a, next 5 seconds means so on and so forth. They can play with that. The omega dash values for this, please remember this formula. They can ask you a question on it anytime. Obviously, you know frequency, you will get the time period. Now the other two things that you have in your syllabus, one is simple pendulum. This is T and M. Time period will be 2 pi under root L by G. Remember that is G effective. If he keeps changing G, it will be G effective. Keep it in an elevator, it becomes G effective. If this is a spring mass system in an elevator is not affected. But this is tension, not time period. This is time period. Right? Don't show tension better. Right? Time period will be 2 pi under root L by G effective. G effective will be G plus or minus A, depending on whether the elevator is accelerating upwards or downwards. One very popular question with the CET test series is, this is a bob with water filled inside it. Water filled inside it. There is a very small hole at the bottom and the water keeps spilling. So effectively this is the length. Effectively this is the length. Right? Effectively this is the length. As the water is spilling out, the level of the water is going down. If the level of the water is going down, the length is increasing. So time period 2 pi under root L by G. As L increases, time period increases. But after some time, when the level of the water further comes down, center of mass will come back.
Yes.
So again retains or regains its original time period. Right? This time period is independent of the mass of the bulb. So when the mass of the water is decreasing, increasing, time period will not change. If it would have been a spring mass system, time period will be affected by mass of the bulb. Right? In a satellite, how best can you maintain the time period? You can maintain the time period using spring mass system. Simple pendulum will not work in a satellite. But spring mass system will work, because time period of a spring mass system will depend only on mass and spring constant. Once again, listen to these swarm of questions. This was asked in 2004 CET. Just listen to it, you will be able to solve it, no big deal. Disk of moment of inertia 9.8 by pi square kg meter square. That means moment of inertia is given. Is rotating at 600 RPM. What is RPM? How do you convert it into radians per second?
2 pi by 60.
Multiply with 2 pi and divide by 60. RPM, RPS. Remember this. Revolutions per minute implies I'll multiply with 2 pi divide by 60 to get it in radians per second. RPS is revolutions per second. Just multiply with 2 pi. Moment of inertia is given. Omega is given. Right? 600 RPM. If the frequency of rotation changes from 600 to 300, what is the work done? Change in kinetic energy. Half I omega square final minus half I omega square initial. Omega final is given, initial is given, I is given. Just subtract. Right? The change in kinetic energy is the work done. Now, the last thing that in SHM that is maximum exploited is phasors. They give you, in principle, this is superposition. Y1 is equal to A1 sin omega t. Y2 is equal to A2 sin omega t plus phi. Now Y1 plus Y2, technically I should add both of them and go ahead, resultant. But instead what will I do? I will take this as A1, I will take this as A2. Angle between them will be the phase difference. Find the resultant and find this angle alpha. This will be A sin omega t plus alpha. Alpha is the angle which resultant A makes with A1. So omega t plus alpha. This is the way you get the resultant. You have n number of waves, they will be combined into it. Suppose I tell you y1 is equal to 2 sin omega t. I will say y2 is equal to 4 sin omega t plus pi by 2. I am taking very convenient numbers for myself. Now what will be the resultant? This will be 2, this will be 4. This angle is pi by 2. So this will be root over of 16 plus 4. This will be root 20. And I know this particular angle. Let me take better numbers now yaar. Let me take this to be 3, let me take this to be 5. Yeah. 3, 5. Now you understood what I did. Hey, 3, 4, sorry.
3, 4, yeah. That's what you were saying.
I'm searching for 5, I wrote there 5. Right. So now, yet tan theta will be 4, sin theta will be 4 by 3. It's okay. Now I will not change anything. Listen. Now what will the resultant be? Resultant will be 5 sin omega t plus theta. What is theta equal to? Tan inverse 4 by 3. Right? Clear? Take this down, there are one or two problems I'll dictate, you'll solve. X is equal to 8 sin omega t, 8 sin omega t plus 6 cos omega t. Question asked in 2005 CET. I repeat the question, listen to it. The displacement of a particle performing SHM is given by 8 sin omega t plus 6 cos omega t, where distance is in centimeters and time is in seconds. Distance is in centimeters, time is in seconds. Find the amplitude of the resultant motion.
10 centimeters.
Find the amplitude of resultant motion. One is sine, the other is cos. How do we bring cos in terms of sine? Omega t plus pi by 2. So you will write x is equal to 8 sin omega t plus 6 sin omega t plus pi by 2. That means the phasor will be take 8 this way and take 6 this way plus pi by 2. The resultant will be root over of 8 square plus 6 square. You get the resultant amplitude. Clear? One important thing with simple pendulum, which in 2006 they have asked. Simple pendulum mein, when you are telling me time period is 2 pi under root L by G effective, remember, take the resultant of all the forces on the bob except for the force which is along the length of the string. See, when you are doing it this way, M, you are not taking T. If you have a pseudo force of ME this way and MG this way, you are telling me time period is 2 pi under root L by root over of A square plus G square. You are taking the resultant of these two. If A is in the upward direction, you are taking G minus A or G plus A. But you are not taking tension. Tension is not coming in the resultant. Why? Component of tension in this direction, T's component will be 0. T is along the length of the string. Component of T perpendicular to the length of the string is 0. Any force along the length of the string will not contribute to restoring force. 2006 they asked you this question where they keep a bob here. This is of mass Q and Q naught. Now what will be the time period? It will be 2 pi under root L by G. Why? Because the electrostatic force will not interfere with the problem, because that will be along the length of the string. Take the resultant of all the forces except for forces which are along the length of the string. Take the resultant of all the forces except for forces which are along the length of the string. One more question which is popular with the CET entrance examinations. Maharashtra CET also asks this. Andhra CET also asks this. Specifically in circular motion, though not rotation. Suddenly a driver sees a wall when he is driving with a velocity of u at a distance of d. What is suggested? You apply brakes or you take turns or you try to turn the vehicle. It's like this. If I want to apply brakes, I should bring it to rest before it collides with the wall. How do I bring it to rest? Force dot displacement should be equal to change in kinetic energy. Minus, why? Because 0 minus half mu square. Final velocity will be 0, initial velocity. Force and displacement will be in opposite direction. Force you are applying is in the backward direction. So minus F into D. So F will be equal to mu square by 2D. This is the force which you are applying to bring the vehicle to rest. Bring the vehicle to rest. To take a turn, what will be your stance? You should turn it in such a way, such that radius should be equal to D. That means the force that you apply should provide the required centripetal force, mu square by D. So that I don't collide with the wall. Which is lesser? This will be lesser. Hence it is always suggested you apply brakes and bring the vehicle to rest. That is the reason why even in the present generation two-wheelers, they tell you use both the brakes simultaneously. Once upon a time, if you people have ever seen this old Bajaj scooters, I learned driving on those scooters 1984. The engine was on one side and it was a very heavy vehicle, small, unbalanced. Maximum speed you can cross is 60-65 kilometers per hour. The body will start vibrating. Very heavy, made of iron, and the engine was on one side. Right? Strictly we were told never apply the front brake. You apply the front brake, the back part of the vehicle would wobble because it's quite heavy. Front part is quite light. Right? It will wobble. So you were strictly told unless and until it's an emergency, don't apply the front brakes. Right? We used to use only the back brake, and back brake was near the leg. The scooter, if you people have seen some old movies, you will get to see if you ever have a chance. It was quite 150 kgs of a scooter that was. Turning that was not easy. It was standard. Whenever we want to, there was no side stand for those vehicles. Side stand, it will break 150 kgs. So there used to be main stand. We used to put that and pull the vehicle back. By default, anybody standing on the other side would help us pull it, because always they know the trouble is so very high. It's quite a heavy vehicle. Later on, better quality materials with lesser weight have come in. Today's Chetak Bajaj scooters are almost of good materials, and the engine is at the center. So now the wobbling problem is removed. And why those days they had to have the engine at one side? Because it was a kick-start engine. So to kick the start, the starter will be connected to the engine. The engine was on one side of that particular vehicle. Right? And hence strict instructions never use both the brakes simultaneously. Now the engine being at the center, you can use both the brakes simultaneously. Here, both the theories will not be applicable. Why? You are considering point object. The question asked also is for a point object, not for Bajaj vehicles. Right? Assuming your vehicle to be a point object, you are giving us the answer that this will be half of that, so that you can apply brakes and bring it to rest. Right? A heavy loaded truck cannot apply the same logic. Their dynamics will be that of a rigid body. You cannot treat a loaded truck as a point object. Quick. This question is quite popular with the CET entrance part. In oscillations, the two main things that are being touched time and again. I forgot one more thing. The other thing that they are touching is if a spring is cut into 3 equal parts, spring constant of each will be 3K. N equal parts, spring constant is
NK.
done. They are asking what if I reconnect them this way, so on and so forth.
Sir, in this case, if suppose that the roads are banked by some angle, then
No, then altogether this is different. You saw a wall, you want to take a turn. Banking will never be given. Right? This horizontal road. You cannot compare a horizontal road with a bank road. Yeah, one spring cut into 2 equal half mils. When I reconnect them in series, I should get back the same. Now this is K dash and this is K dash, right? Now when I reconnect them, 1 by K dash plus 1 by K dash is equal to 1 by K. 2 by K dash is equal to 1 by K. K dash is equal to 2K. This is the precise logic between them. When I connect them into, cut them into n equal parts, and I reconnect them this way, I should get back the original K. Now, where they can play with you people is, n parts, 3 parts, 4 parts, you are okay, 4K, 3K, so on. What if they cut not in equal parts, 2:1 ratio? What if I don't cut it at the center, I cut it at 2:1 ratio? K will be the inverse ratio of the length. Whichever is, if I cut it, this is 2/3, this is 1/3, right? If I cut one spring with this length to be 2/3, this length to be 1/3. Now the 2/3 length will become K by 3. The 1/3 length will be 2K by 3. Clear with that? This is something that they are playing with. In oscillations, two main things. One is phasors. The second is time period, simple pendulum, damped oscillation, and the third phasors, simple pendulum, damped oscillation, and the third is this, spring constants. Oscillations, these are the only questions I saw in the last 10 years of CET papers, quite easy to score here. Okay, HSC textbook के formulae भी याद रख के जाओ, you will never go wrong with anything. Use balanced approach, don't be over anxious in solving every possible question. 90% questions भी solve कर लो ढंग से, बाकी 10 guesswork मार के आ जाओ. And whenever there is no negative mark, please remember you will have to mark whole of the paper. 90% questions you have solved. Last 2 minutes you are left with only 3 minutes. You cannot solve those questions. Blindly mark C option as the answers. C. 1 in every 3 questions will be correct. Mark C as your option. Third bit. 1 in every 3 questions will be correct. So don't leave the paper under any circumstance. Mark it completely. Fine. But do that after solving the paper. When you know that last 2 minutes you don't have no more time, mark all C and walk out. Mainly semiconductors and those parts will have to come quickly because that part is important. वहाँ से every year there is one question. That's what next class I am planning to shift from behind instead of doing this. These things you people will resolve. But elasticity is important. Mechanical properties is important. Mechanical properties से एक question आ रहा है. Elasticity, surface tension, then wave motion oscillation. Then I will come to it.
Sir, next class what topics will be?
Elasticity, surface tension, mechanical properties.
9/2.
Next class.